Check, hello. Check, check, check one, hello.
Good morning. There's a small announcement. For all the dignitaries of URSC, high tea is arranged in the ground floor. Kindly join for high tea in the ground floor, the URSC dignitaries. Thank you.
Check, check.
There's a small announcement. Participating students who have still not had their breakfast, kindly go to the ground floor. This is a request again. Students who have not had their breakfast, kindly go to the ground floor. Please have your breakfast and come. To all the other dignitaries, URSC employees, high tea is arranged in the ground floor. Kindly go and make use of it. Thank you.
Hello. Suraj, come. This you would have seen.
Yeah, already seen.
So in this you have got some clarity. Up to scanning, they have to do with single command at least.
Okay.
There is no scanning involved, no autonomous at all.
Correct.
Okay. Manual, if they are doing only encouragement, no marks anywhere. And see, takeoff and scanning we are giving 2 marks.
Correct.
If they are restarting again, okay, I will explain them. You also remaining thing you will immediately get there. You will reposition one side. That one fellow from this side will be there. And later I will be organizing that one. Good morning, sir. Sir, all respected expert panel members. So I will brief now how the evaluation, like the guidelines. So, sir, you can see you can pick the paper IRoC-U 2025 evaluation guidelines final round. Yeah. So coming to the arena. you can have judgment, and total marks are 45. I explained. Explained. Okay, sir. Sure, sir. Yes, sir. Sir, you can ask in everybody.
No, you are asking them to scan. What I just want to know is, after they scan, are they supposed to show you something like this?
Yes, sir. Yes.
Correct. No, that means
That
who's going to
laptop-
evaluate this? Will you be able to evaluate this scanning thing?
Sir, they will be showing the telemetry and the topology on the
We
screens.
will come to know. Now, how we will come to know that?
They will show on the screen, sir.
Show on the screen is what?
They will show on the screen, or they will tell us what are the coordinates they have found
Units,
relatively.
because you have written in feet here. No, some of the units are little, I don't know.
So basically,
Some are
sir,
in mm.
yeah, for this one, sir, regarding
feet, I
the actual coordinate location will be shown in the telemetry. The actual visualization may not be available online. So in the offline mode, they can actually show us what map they have created.
So what?
Yes, sir.
So what is this unit here? Oh, this is in meters. Yeah. Meters. Okay.
This one, sir, 4 meter by.
ಅಲ್ಲ ಇಲ್ಲಿ meters. ಇಲ್ಲಿ 4.8 sir.
Saurabh is here only. Because sir, exactly because actually what happens is navigation algorithm will pick some point based on the variation in the map. So it will exactly not pick the section also. So it may pick people on the boundary, so they will land on the boundary. So 1:4 kind of. More than 1:5 ratio. Actually, this is much bigger than what they had in their own trial rounds. They had it much smaller.
Number of attempts. Hello. Sir, one more thing. For evaluation marks, the rightmost top eval marks 1, 2, 3 Roman numbers are there. Those columns are for re-attempting if they are doing, and if they are getting more marks, yes, they can be allowed. If they are restarting in the second attempt, and if they are performing better, they can be that can be considered. So for that we have given first attempt, second attempt, third attempt. Any more attempts, I think we have to write behind or somewhere, sir. We will give one more sheet. It can be requested.
Yes, sir. Just
Yes.
bonus.
Yes, as the gap is there, you can add. In case not, then we will get one more sheet for that.
3 attempts, but here the bonus marks will come down. So in the first attempt only they are doing, the bonus mark is 6, but in the second attempt the bonus 2 marks will be there.
Autonomous only we are allowing all the attempts. So autonomous in the sense end to end they have to do. Yes. So if they are doing anything in break,
20 minutes
piece,
the battery can sustain. 20-minute battery can sustain.
nearly, sir.
Charge battery.
For individual teams it will changes. Yeah. Sir, in the we have given the top team list. In that they have given their features. So when they come, you can just go through that. This is the one, sir. Yes, sir. Yes, sir. Sir. That will be considered, sir. Because they have done that autonomously completely. Only for bonus marks of that number of attempts second, that alone will be cut. But this entire execution they have performed. Yes, sir. Yes, sir. Yes, sir. Yes. Yes, sir. Only bonus marks will change for the number of attempts. Bonus marks will be given here. Yes, yes. Sir. Now we will announce, sir. Saurabh. Okay, I will get the teams.
So your leader is ready. That other day she told actually यार वो crisis में लेके आते थे हैं हाँ yes so they are bringing to Astra test that now they are I think breakthrough
Rest of the teams can leave, please.
rejected software see
or who is the next team who is performing. If that is available, we can put as a PPT. So what I request is, okay, because today, tomorrow, 2 days event is there, so ask somebody to prepare a PPT, one team. So next
Nikhil,
meeting,
sir, can you once contact Nikhil? Nikhil? Here, Nikhil. That team-wise, time-wise, slot can be, somebody can make a PPT.
if there is one slide.
Sir, the papers are flying. Yes, sir, yes, sir. Some more fans are kept. Okay, okay. Already 40 minutes.
Which college first? That's what I asked. Hello, Table. So the DD I told that you and Bhagwan take care that budget meeting.
Shravan, we need to ask. You can.
Okay, you take care that this one. DD is the main chairman. You take care that any no concern, no? Do you have any concern? Huh? No concern. Then okay, no. Anything is there, okay, no problem. You tell that IRoC-U staff is there. What they are in that tell. Okay, no problem. దినాకర్ అయిపోయిందంట నేను ఇంకా వస్తాను
Now all components are ready. You are ready. So I can declare. Okay. Anyway, so I'll declare team 1.
and you have to select it.
So, good morning all. So now the first team is team Astra. We are starting at 9:35. They are from Indian Institute of Information Technology, Design and Manufacturing from Kanchipuram.
Good morning, everyone. Our expert panel is here. I am part of the expert panel, and our esteemed colleagues are there, and our senior members are there who will be evaluating your actual challenge. So I hope you are aware of, your team is aware of all the requirements. And this is first you may have to select a home position and heading position among 5 possible cases. You may have to select one of them. They will immediately arrange the home position there, and from there you are supposed to
We are going to go, will we scan whole arena so that we can generate the map. Once we'll be having the map, using the flat surface detection algorithm, we'll be finding the wherever the flat surface are there in the map.
You don't have a problem in the heading. Heading, okay, anyway, you selected, Sairam? Sir? He has selected the spot position, home spot 2, and heading towards north.
Okay.
So probably,
CNMG?
I'll put it back in.
Home spot 2.
Home spot 2 and north heading. So in case you have difficulty, you try, no problem. Just attempt that. Okay, that's it. There should not be a problem.
Approximately. Yes, sir, yes.
So we can start the Q&A also in case if the time is there. Your configuration of the this one you can say what type of configuration of your system? System configuration.
Yeah, sir. Our AVNE, the weight is under 2 kg. So the flight, we will be using the optical flow sensor for the navigation.
Weight scale.
Optical flow sensor for the range, for the altitude measurement, as well as the inter-real sensor, inter-real sense camera for the X and Y for getting. After that, the flight time of the drone is like 13 minutes with 8000 mAh battery, and the drone is like the kit we have bought from the shelf, but some modifications we have done. Like this is we have designed our custom Jetson mount by ourselves, camera mount, battery placeholder, and the landing gear from ourselves. So.
Yeah.
Yes, sir.
What is
Yes, sir. First, we will be doing the simultaneous localization and the mapping. So we will be generating the map of whole arena. So using the stereo camera will be facing the downward side. So it's like a stereo camera, depth camera. So it will generate the depth map. Point cloud data will be getting continuously. So once we'll be having the map, we'll be receiving this map, and on this map we'll be applying our DB scheme algorithm, so that wherever the flat surfaces are there, the even surfaces, it will detect whatever the width is there, 5 cross 5 feet, and it will land over there.
So you also, the periphery identification also is part of your task. You will be able to identify this periphery because that is colored specifically for that purpose.
Yes, sir. We will detect the flat surfaces only. Flat surfaces we can detect without any.
Okay. Now, which are the sensors you are using to do this task total?
Yes, sir. So, we are using Pixoc flight controller, in that inbuilt gyroscope, accelerometer, barometer, and the magnetometer are there. External sensors are the optical flow sensor with a rangefinder. So optical flow sensor give the X and Y, and the rangefinder will give the altitude. So optical flow sensor will be using.
Okay. Now to check this boulder, what is the size you have taken? How much size it will detect?
Detect. So 5.
Boulders. Here so many obstacles are there. No?
Yeah. So for that, in the flat detection algorithm, we have set the threshold. Okay, like in 0.9 threshold, like how many like obstacles are there, so we can avoid and we can detect there. So.
When it is coming down and when it is about to land, what is the scheme that you have used?
Sir, first it is detecting the hotspot. Once the hotspot is finding, we'll be using the ROS 2, okay, for the navigation purpose. ROS 2 with IRO pilot firmware. So our ROS 2 node will be running.
Keep it away from your.
Yeah. So our ROS node will be running continuously. In that we have implemented our navigation algorithm. So first it will start from the home position. So far it will scan the whole arena.
Asking you, how, when you are landing, what is the scheme that you are using? How do you navigate to your ground?
So yeah, once we have received all the safe spot coordinates, we will be passing this coordinate in the form of array to our navigation node, and we'll be going to this all nodes to their hotspots, and we'll be landing over there. We'll be using the landing command for the landing over there.
Further details, what do you mean by landing command means? Say suppose you are at 10 meters, you are at 2 meters, you are at 3 meters.
Yes, sir.
How do you navigate to that means how frequently you are going to measure the height? Is there anything like that?
Yes, sir. The height estimation will be getting from the optical flow sensor in the QGC ground control station. So continuously the height measurement, like we have set the 3 meter maximum height, we won't be going above 3 meter. So our drone will be at the same altitude. This altitude will ensure ensured by our optical from camera, as well as the code which we have written in
Abhishek, just about the task, what you are going to do. You are going to do scanning manually, is it? That's what you are
Yes,
saying.
sir.
Then how do you decide which spots you are going to attempt? All will be as per, you will manually do, or?
Yeah, sir. Hotspots coordinates will be receiving in our PC.
Okay, after the scan is complete, you will demonstrate what are the safe.
Safe spots, but we won't be landing autonomously over there.
Okay.
We'll be landing manually on hotspots also. But
Manually.
the coordinates will be receiving there because some hardware issue is there
Fine,
yesterday.
okay, go ahead with that. And you will be able to land on the 15-degree slope as well, isn't it?
Yeah, sir.
There
We'll
should be.
try.
And there are 2 more tasks for you that you may have to demonstrate the link failure and battery emergency.
Battery failsafe.
It's possible,
Data.
you will be able to do that.
So data link loss if the drone goes out of arena.
Okay.
So if telemetry loss is there, so for that it will be risky, but battery failsafe will try to.
Okay, you can decide because that doesn't carry a much. You can decide on that. Okay. So you also have 3 attempts. You will try to do in the first attempt, I hope. It's okay. Anything you can take any
Yes, sir.
3 attempts. Not a problem. You have 45 minutes time.
Yes,
If it is
sir.
set up, we can proceed with that.
Yes,
huh?
sir.
Yeah. Any other questions? Sir?
Sir, their drone is weighing 2 kg exactly. It can be noted down.
Okay, fine.
Yes, sir. Thank you, sir. Thank you, sir.
All the best. Take care. No issue there.
Drone can be kept. drone can be positioned northeast that direction. You need mic. The mic there.
That is north. That is north or this is north?
Then how he will be able to operate it? Who
North.
whatever is doing that is fine, but that laptop, everything is connected to that laptop.
Three pair of this are there. That is what is that
Top, sir.
corner. That is the starting point. From there, every time it is in position. Yes. Yellow thing is there. Very nice. Hey, this
Sir, since they cannot connect directly because of Linux, their laptop we are putting to you on the screen. This is a screen where you can see their things.
Their telemetry, sir.
That port, no, it is not working. This is a laptop screen. Actually.
there that yellow this one, no? That just
That will pull it, sir. We'll pull it, sir.
adjust.
CNDNG team.
Hold here, because I asked them to switch out to DC. Power is going coming.
Yes, yes,
So once it clears, I will tell you, then they can start.
Sure, sure.
That side okay, no? That side okay.
Shravan.
Change to DC now. No power will not go.
Sorry, I'm not getting you. Tell me. Yeah, tell me. Mustafa, tell me. Okay.
They are having some difficulty. They will come back. The second team is going to set it up. They have some difficulty in communicating with the this one, actually, drone. So mostly it was interference. Now even if they stop, there is some difficulty in the contact. They will do. Good morning. The second team is ready. The team is Team Astro Martians from KCG College of Technology. You can just introduce the configuration and we'll just. And I know that you know the competition details. So you have to select one of the home spots and the heading. Both have to be selected. Based on that, your home spot will be decided. And your challenge is to hover and find the safe points and then land at 3 spots and then return back. So this is a primary challenge. And you have the choice to do it fully autonomous or semi-autonomous after identifying the safe spot if you demonstrate, or manual. That choice. And you have 3 attempts also. You can make 3 attempts to do that. And you also have to say if there's a illumination, any requirement is there, you can tell. Do you have any special requirement of illumination? If this illumination is okay or not, you have to tell. Okay, that you do. And you can explain your configuration. We'll go further.
Okay. Good morning, staffs. I am Jarnes from KCG College of Technology. Jarnes. So we are Team Astro Martians. So we are from KCG College of Technology. So we are a team members of 8 members. We are a team consists of 8 members. So our setup is, our ANAV is based on Jetson, and a depth camera or a stereo vision camera called as Z2i, and then Pixhawk flight controller. This is the main setup we are using for the scanning the safe spot. For scanning the arena and landing on the safe spot. So the main scanning logic we are using are, so while the ANAV will starts takeoff from the home position, and while arming, the ANAV marks his home position. While arming, the Pixhawk will enable the home position by using the visual inertial odometry, which is given by the Z2i camera, so which is continuously goes to the Pixhawk. So by using that, while we kept on the home position, it will automatically captures the home position while enabling, while arming the drone. So by using that, home position was enabled, and after that we have programmed to take off to the height of 2.5 meters or 2.3 meters. So after that, it is going to scan in a lawnmower pattern. So it will be like something rectangular lines. That is lawnmower pattern. Why we have choose that? Because of like it will increase the battery lifetime, and it will be more safe to scan, and to not leaving the boundary, we have made geofence. So by using the, instead of GPS, we are giving the VO coordinates, that is visual inertial odometry from the Z. So by using that position coordinates, it will not leave the yellow color arena. So coming to the scanning, so after takeoff to the height of 2.3 meters, it will start to scan in the lawnmower pattern. So while scanning, it will, the Z2i camera, so already what I have said, Z2i camera, that will generate a 3D map by using some SDKs. So ZSDK, called ZSDK, by using that it will generate some 3D map. So what we have programmed is, by scanning the arena, we have divided the arena, which is 12 meter cross 9 meter, we have divided the arena into the 432 grid cells, where each grid cell is 50 centimeter cross 50 centimeter. So this side 24 and that side in 24 meter, sorry, in 12 meter scale, there will be 24 grids, and in 9 meter scale, it will be 18 grid cells. So totally 432 grid cells will be there. We have divided the arena into 432 grid cells, which is where each grid cell is 50 centimeter cross 50 centimeter. So we have gave the conditions for safe spot, and I have gave the condition for hazardous zone and flat zone and grouped flat zones. So what does the hazardous zone means? Like based on the rule book, they have given conditions height will be lesser than or equal to 1.5, sorry, height will be greater than 1.5 meter and lesser than or equal to 2.5 meters. So I have gave that also, and the terrain, the hazardous zone will contain many obstacles, and that will be not a flat zone. So that grid cells will be displayed in red color. And again, the flat zones which doesn't have any obstacles, that will be displayed in green color. So in that 2D map, which is divided into 432 grid cells, hazardous zone will be displayed in red color, and flat zones will be displayed in green color. And then the grouped flat zones, which are identified as safe spot. Like our safe spot is 5 feet cross 5 feet. So converting it into meters, it is around like 1.5 meter cross 1.5 meter. So it will consist of 3 cross 3 grid cells. So 3 cross 3 grid cells. So the grouped grid cells will appear in blue color. So this is how we have coded. So the groups, after identifying grouped flat zones, it will send the coordinates to Pixhawk. So this coordinates will be in the format of E and U, east, north, up. And Pixhawk doesn't accept that, and for Pixhawk it will take NED format, NED coordinates, that is north, east, down format. So that will be changed into NED format and sent to Pixhawk. After sending to Pixhawk, Pixhawk's mode is converted into RTL, return to land mode, and after that it will land to the system.
Okay, very good. You have to pick one spot and the heading. Just choose one.
You explained how you are going to identify. Hello? Yeah, you explained how you are going to identify the safe zone. Now, after you take off, and you told in a lawnmower fashion you are going to scan
Lawnmower
it.
pattern, yeah.
Okay. Now, when the whole thing is being computed, is it still hovering or what?
Sir, whole thing.
No, you have got to compute the safe zone in this entire area.
Yeah.
Will it still be hovering there, or as it is moving, it computes the safe zone?
As it is moving, it will compute.
Okay, that means after the entire scan, you're going to identify the safe zones and you're going to land
Yeah.
it. So by the time it completes the last scanning, it would have identified the safe zones.
Yes. So after that, it will the mode is transferred into RTL. So then Pixel will return to.
Okay, fine.
Okay, you are ready with the demonstration?
Yes.
I can proceed. Okay.
So first we are going to try manually and semi-automatic and then autonomous. Yes. Jarnes Keba Ebenezer.
Zernes,
Yes,
I
sir.
have one question.
Yes, sir.
So your flying machine is having certain weight.
Sir?
Certain weight.
Yeah.
And it generates some lift also.
Yeah.
What is the maximum lift to weight ratio of your machine?
1.5 is to 1.
1.5 is to 1.
Or 2 is to 1.
2 is to 1. 2 times it can lift. Okay. And do you have this? You have integrated. The structure is made by you, or everything is bought out and then assembled?
No, sir. We have bought and we have integrated.
You have integrated.
We have bought the Jetson and Pixar from separate websites and we have integrated it.
Integrated.
There is no available setup. Is not available. We have integrated all three things.
Journalist, first you are going to try automatic or
manually?
Manually, you are going to lift from here, and that scanning you will do manually or automatic?
Sir, that will be given in laptop, sir.
Okay, okay. And then you will demonstrate the green and red zones in the
Yeah.
laptop. That's what is first you are going to demonstrate. Okay.
1 minute.
Go ahead, please.
Timing will start now. You are ready? Okay, when you're ready, you can.
Okay, anyway, we'll note it and then this one, please. You can start. After that, you can ask for using the share. See, it's even if you say to show the green and red.
One screen, this screen. Other one, that one. Both cannot be same. One has to be a drone. Sir, one will put drone screen, one will put laptop screen. Is that okay so that both can be synced? This is getting webcast or recording?
The processor board battery is down, but that's what he's telling. So, because either they have to keep the charging nearby, so they'll go and come back. I think we have to call the next team.
Sir, team 1 is ready, the team Astra. Shall we give a chance to them? Yes.
Let them straight go for demo. You take
Okay, Team Astra is about to start. Yeah. So your time starts now.
Should not break. The flatness, any problem with that? I don't know. May not be. Huh? Huh? May not be problem with it.
Venu, can you keep in center? Yeah, yeah, that's fine. Yeah, yeah. Good.
One of them is not genetic, same is not genetic.
Last time I did observe. Now I felt one was not rotating.
Venu, the landing gears.
First hotspot. Land it here, land it here. Then, no, proper hotspot, proper hotspot. telemetry.
No, they are going, sir. Team, you can declare whether you are doing in autonomous mode or manual mode. You have given a mic. You have to tell whether you are doing in using RC or autonomous mode.
So we are using RC to command this.
So it is completely manual.
Yes, this is completely manual.
Yeah, the scanning will be done. You are trying to do scanning? Or?
Landing is also manual.
Okay, noted. Okay.
So there is battery failsafe. Battery voltage is like less than 11.2, so it won't take off again. Again, it will land.
Okay, it has gone into safe mode, is it? Battery safe?
Battery failsafe.
Okay.
So battery is like below the voltage, whatever the range we have fixed.
So what is the voltage right now?
You
can enter. You'll be able to see there.
So if you have to see. So sir, first is battery failsafe. Second failsafe is, we can see here in QGC, the potential thrust loss. Okay, because of the battery failsafe, the thrust there is like difference between the thrust of both the diagonal motors. Then it will also land there. So because it will crash if the thrust dismiss will be there. So this also activate. Yeah, you can see here. Yeah, here second failsafe is like thrust loss. If the thrust occurrence is there, like if diagonal motor thrust is not same, then it will tilt or it will fall down. So then it will, because of this, it will landing. It is not taking off at a certain height. Is that? Yes, sir. Yes, sir. Not full, so it is like 11 point. Again, we need to check how much voltage is there in battery.
Okay. Okay, now.
Yeah, I will check one more.
Yeah, now how much? Okay. 9 minutes. Okay. Are they having some more time to do something? Or? Battery is down, is it? Okay. No, you can have it. It's good. Don't worry about that. It's okay. Very good. Excellent work. Don't worry. So now you decide how much to.
some failsafe is activating because of that, I think.
Okay, very good, very good.
So, yes, sir, we want to explain our approach for the friend.
And then,
yes, sir.
now, Abhishek, you can just explain what has happened, and it's excellent work.
Yeah.
Excellent demonstration. You go ahead and explain to the team. Yeah, come. All the team members can come and then just explain the activities. Yeah, please.
So what we were doing basically with manually we'll be launching and we'll be scanning the arena. So after scanning the arena, the flat surface detection code will run and will show the flat surface coordinate, okay? And we'll be landing over there in flat surface manually. It won't be autonomously because of some hardware issue. So that's why, but scanning we didn't complete 100% till there. So whatever the detection is there, the hotspot, once scanning is fully done, then only we'll get the hotspot coordinate. Because of scanning is not fully done, so we didn't get the hotspot coordinates till
You
now.
were able to get the data from the scanning?
Yeah.
You were able to get that?
Can you show that data?
Yeah.
Would you come here?
Yes, sir.
Other team members can come. Please join all members. Yeah.
You can, yeah, sir, that is also scanning. First hotspot. Yes, sir, scanning was continuously, simultaneously. Yeah, simultaneously. Sir, we will show the coordinates.
So did it scan some data? Just we wanted to see if it had scanned and demonstrated something. Okay. Safe spot mode, it went. Did it identify the spot or no? No, did it identify the spot? No.
These are the points.
Coordinates from the home.
Yeah, from the home. With respect to that as a home, it's like
Okay.
but landing we did it manually. But
Okay.
these spots are by the survey.
Okay.
So that file will be.
Identify that is a safe spot.
Okay, so we can explain our algorithm.
How much meters it traveled, you tell? From this spot it identified, no? It went. The IMU showed this much difference?
No, sir. Sir, this is like just the safe spots. You can see it here.
Okay, we know. Did you output IMUs during the stop?
No, sir. This is just the coordinate points we can get.
This is a coordinate from the home, is it?
Yes,
How
coordinate
much
from
is showing? Can you just tell from home?
This is the 8.2 and 10.8.
From the meters, is it? From the home. From the home.
Yes, sir. From the home.
8 is slightly higher. Around, sir, from around 5 meters or from home. Yeah, okay. Second, correct. 4.2. That order should come. Other set.
Order we can't get.
No problem. The first spot.
Okay, so the points for where we landed is something we did manually, but because of the scanning, whatever is generated, that is shown here.
Okay.
So where we landed and this point can't match.
No problem. We are looking at
That's
from.
we don't know whether it matches.
No, from the home.
Yeah.
Whether it is identified as spot in also.
No, from the no, is it?
We'll get the PCB data like as a whole, like the point cloud data, the entire arena from the scanning.
Mic.
we'll get the entire point cloud data from the map. So the order of the points here will not be the same as the order in which we surveyed. Like when we surveyed, this is the first safe spot. That won't be the first one here because our plane detection code will get the overall data and it will try to publish. So this 1, 2, 3, 4 is not the order of the safe spot.
Okay,
it is
this is
just
four.
arbitrary
This
number.
is four
so
safe
these
spots.
are the number of safe spots that were identified. So they are not in order.
In the first attempt, when it lifted, it identified. You are telling.
Or you mean say, if you have completed all scanning, next time when you would have gone, you would have landed to these points exactly?
No, sir. That's what, sir. The landing is done by manual. The landing, what we did is pure. Yes, sir.
First manually you are doing everything.
Yes, sir. Yes, sir.
You are identifying the entire terrain.
Yes, sir.
Next time,
yes,
when you are trying,
yes,
let us say you are putting in auto, giving this coordinates,
yes, sir.
will it do automatically and then
Yes,
land it
the
there?
code what we wrote is we'll publish this to the autonomous code, and this will try to survey all this safe spot.
Okay. I think first they will map, then only they will activate these points. At that time it will happen. That's what they are doing.
You are having some 4 lines there. No?
Yes, sir. 4 points.
4 points.
Yes, sir.
All those 4 points are very close to that. All are different, but from there it looks like only that is the safe zone, no? You haven't come till here, so how you are getting 4 points?
After mapping and understanding the terrain, next time they will feed these coordinates whatever we wanted, whatever the coordinates say point 1, x comma y. They will put it, and then next time if they are successful, they would have gone to land at the same points, 1, 2, 3. That's what they are trying to tell. Is that correct?
No, okay, I have a question. Now using joysticks, you visually seen and moved. How you disprove this? No, I am telling from these joysticks, by seeing this I can operate the drone so that it can move. How you disprove this?
Sir, actually what we done is we manually manual takeoff by seeing only the safe spot. The mapping.
No, I am telling you are not identified space spot.
Okay.
I know where to move. Simply using joysticks I have moved.
Yes, sir. Now
have you done like that or that's what?
The landing and taking off was manual, correct? By controlling the joystick only you did.
Everything, whatever the drone did is manual.
Only what sir wanted to ask is, the first attempt was to identify the safe. That it is demonstrating 4.
Yes.
You didn't use that, and you manually went and landed.
Yes,
That's
sir.
what you were trying to say.
That is what we had done.
Yeah.
Yeah.
My question is, you started from there.
Yes, sir.
Okay, you moved this way.
Yes, sir. We moved this way.
Okay, you moved from there to there.
Yes, sir.
To see the terrain, how many safe spots are there?
2 we are.
You have identified that also?
We landed here.
No, that manual.
Mapping had happened.
Then how come you are getting 4 here?
I guess based on the accuracy of our thing, it might have detected other spots also safe. That
What
is
is your criteria for identifying a safe spot?
The dimensions, sir. 5 cross 5 feet.
What is the unit?
Feet, sir. Feet or
5 feet. Do you think these things are okay? Are you having 5 cross 5 safe zones at 4 places?
And 8 meter, 10 meter also slightly higher. 8 meter and 10 meter also is there. Okay, Abhishek, really an excellent work you people have done. Very nice to see. And coming to this, yeah, tell.
We just want to explain what is our approach for the plane surface detection. So C has worked on that part.
Right now, we just showed what are the safe spots that got published, though they are not as accurate, but how those safe spots got generated, that is by a particular approach.
Right. That's good. You showed.
So basically, when the drone takes off, the camera, the field of vision of the camera captures the arena. So based on that, the code will divide the arena into grids. And we can see from the right of the camera, this is a 3D space. So there will be 3D point cloud data. So that it will try to map it into a 2D space. So from 3D points, it converts into a 2D space. And then each point will be evaluated or valid or invalid based on whether it is a flat surface or not. So suppose if you see wherever there are stones or wherever there are undulations, there it will be marked as a red like an invalid mark, while the places where there are safe spots will be marked as green. And since there is a safe spot which is tilted at an angle of 15 degrees, we also included a check so that safe spot is also considered and not just as an undulation but also as a valid safe spot. Now the code will accumulate all these safe spots. So all these black place is all uneven terrain, while these places are safe spots. This is just an image to view, it's not the exact arena. And then we perform something called distance transform. Basically what it does is, it will try to calculate the distance of each point from the nearest non-safe spot. So if suppose that is our safe spot, it will try to calculate the distance of each point in the safe spot which is farthest, which is its distance from the non-safe spot. Suppose say that stone. And it will try to give the coordinate of the point which is the farthest from the uneven terrain, so that this ensures that the code doesn't give a corner point of the safe spot as a safe landing zone. It is supposed to be in the center. Suppose if it gives in the corner somewhere, like even if you see beside the safe spot also it is a little bit flat, but then there is a stone there. Maybe if the coordinate is just a single point. So if the coordinate generates there, then what will happen is the drone will try landing then and it will clash with the stone. So we perform something called distance transform and peak extraction to ensure that the drone lands in the center of the safe spot. Yes.
Okay, very good, excellent. You also had some safety thing triggered, you told, no? What are those safety things?
So some safety features we have put in the QGC. Battery failsafe, if the battery voltage is below the 11.5, the drone will land there itself in autonomous mode. So here, like we are doing manual, so that also it was not lifting because below the 11.9. Second is data link loss. Let us say we have disconnected the telemetry from the ground control station. So drone will land there automatically, or if the scanning is not completed, so it will find the nearest hotspot or it will land over there.
You had some differential thrust also you showed.
Yeah, differential thrust. So if the diagonal motor thrust is not equal, so in the QGC by default one parameter is there, okay? So it won't hover, okay? It will try to land in any of case.
Okay,
So
you had initial problems due to differential thrust, some...
Yeah, while testing, we have faced there only in the main arena many times this.
Okay, okay.
One question here, excuse me. See this, what you have done is that actually that you have manually you have done.
Yes.
During that time, what are the sensors are active? All the sensors are performing, or that is it okay or not okay? Suppose
Yes, sir.
height measurement. You
Yes,
have
sir.
put that barometer, that height related things,
Yes,
and
sir.
vision sensor is there. How
sir.
much height is come? Whether it is background, you have verified the telemetry that all the height is
Yeah,
proper.
sir, yeah. So in the QGC itself, live data was showing, so the height was accurate.
No,
The-
but with different sensors, you have seen that both sensors are matching that.
Yeah, exactly.
That only we wanted to see. Other thing is that differential thrust was there.
Yes, sir.
How do you manage that with the differential thrust? Suppose if it is differential thrust is coming, but your modulation of the speed you have to do. That is
Yeah.
happened. Have you
So
checked that?
in the autonomous mode, generally, if some like due to wind push or something, the thrust will like deflect. That time it will land. But in the manual mode, might be use a pitch or roll or some more thrust we have given. That time the error has activated.
No, your manual mode also. Is it that any algorithms are running? What are the algorithms running? Output of that algorithms?
Yeah, sir. For first the scanning, it was continuously scanning.
Scanning.
Yeah.
The scanning map is built up to that point. Map is built.
Map was in Judson only, so we were just receiving the coordinates after the map.
Map is there.
Yeah.
Up to that point, at least that first portion.
Yeah, yeah.
And the second portion map we could not see.
Yes, sir.
Okay, that map. Sometime you can show that whether map is properly it is built or not.
Yes, sir.
Okay. What else other algorithms are running when we are manually moving?
the plane detection algorithm is running so that we can.
Okay.
Through the plane detection algorithm only, we were able to see the safe spots being published on
Okay.
it. So the algorithm was running on our companion computer, which is Jetson Nano. We were able to see the coordinates, which was the output of that algorithm in our system outside in the.
Now, can you do the autonomous now?
So, some battery issues.
Okay.
Sir, basically,
Actually, on 2 occasions, it did not take off only, no? It tilted, toppled. What is the reason?
sir, first one, the battery failsafe was activated, and the
No, just
that
tell again, repeat again.
from the second thing was like what I feel is the optical flow sensor. No, so it is like downward facing. Okay, so position estimation was not that much accurate in the that time.
So what I didn't understand is when you're operating manually, why it toppled?
So manually in the manual mode also we are not doing fully manually. We are getting the data from the optical flow sensor. So it is for the stable flight it is required. It is not manual mode. It was the loiter mode. In the loiter mode we are getting the data from the optical flow sensor X, Y as well as Z. So this X, Y or Z data optical flow sensor give to the flight controller, or based on that it will take off smoothly. So if we don't use the PCO roll for the takeoff, we just use the thrust. Okay. So other things it will automatically take care of the optical flow sensor itself.
Okay. Okay. Excellent.
So actually, what we were doing is we were publishing in XY. We didn't have exact control on the motors. So if there is any issue with the sensor, that's why it was toppling.
When you're operating it manually,
Yeah.
what is it that you are doing?
We were just publishing, so we had thrust, that is Z, we had pitch, that is X, and we had roll, that is Y. So we only had control over all this three. We didn't have control over the RPM of each motors. So if the sensor which is giving me the localization, that is the optical flow sensor, if that gives me some junk data, then it will fail. So that was the issue, it was stopping.
Here one question.
Okay.
Just
Okay. Excellent performance. Excellent. Good. You did a very good job. Yeah. Tell only one. Yeah. Tell.
So basically, this is the place in our campus where when we were testing our plane detection code, we were able to generate this map.
Okay.
Now the map will be in Jetson. Since we disconnected, we can't retrieve the map.
Oh,
now.
it is lost. Then it's get powered off. Okay.
After we powered it off.
Okay.
So
Okay.
basically, the code runs, and this is the what we showed earlier.
This is what the unit meters.
This is in meters, sir. Meters. So if you map these points on the point cloud data, if suppose if we were able to retrieve the map from the Jetson, and if we map those points,
You get it done and show. No problem. This is what you have done in your college.
yes, sir. This is the code running, and these were the same code. As you can see, the code was able to perform well in that environment.
Okay. Very good.
Able to detect the safe spots almost accurately.
Very good. Very good. Very good. Team Astra and team. It's
Thank you, sir.
If you are able to demonstrate that data. Okay. Good. Thank you. Thank you, Team Astra. Okay.
No, they're charging.
All the different symbols. No problem. I also consider. No problem. So you are this one. And one is the innovation prize. Next time, I have to create
Are you ready?
Galactic.
You can finish your introduction. You can finish your introduction, team introduction and your details. Then you keep a laptop here. Wherever telemetry is there, that should be shown here. That directly putting. Okay. Yes, that. So then we will declare the start of the time. After that, so after introduction, should I explain how they will Yes. Please, you can go. One person can go there. Rest of the team can stand. And also, sir, can I ask one more member to join me? Yes, please. Yes. Go ahead. Yeah. Thank you.
Good afternoon. You are from Galactic Gearheads team.
Yes, sir.
Yeah, if you want to set it up, you please parallelly somebody can set it up. You
Yeah,
just
sure.
briefly explain, and I know you know the competition, isn't that? You have to choose one for the heading and one for the place. You can
Okay,
just
sure.
choose it now.
Right now?
And then yeah.
Okay. One.
So east, and then this is almost same there. Okay, same only. I'll put it. They have chosen east, the same point, east heading, that is they have taken. And from the home point, you have to demonstrate either autonomous hovering. Autonomously, you have to get the mapping and find the safe spots, and then land and come out. Okay,
sure.
You can also, you have a choice to do autonomous or manual, everything, it's left to you. And if you are able to identify the safe spot, it's good. You just show whatever is, you can decide what you are going to show also, you explain. And also, if you have any choice of the lighting or something, that also you have to tell.
Okay, sure, sir. Understood.
Okay, good. Briefly explain. If you have any constraint on battery, go ahead with the actual.
No, I'll explain first.
Yeah, fine. Go ahead.
So, good morning, everyone. My name is Nimish, and I'm the team captain of Galactic Gearheads. And I'm representing Pune Institute of Computer Technology from Pune.
and this is our drone Swastik. So basically we are using a noble scanning method where we create a depth map using a 2D LiDAR, and the depth map is of 2.5 dimensional. And for localization we are using an optical flow sensor. Actually the optical flow sensor is not a ready-made one. We are using a Raspberry Pi camera, and we are using a self-made algorithm for localization. And talking about the architecture, for processing power we are using a Raspberry Pi 5, and the Wi-Fi transmission for the connectivity between the drone and the base station is done using an ESP, because ESP gives a better bandwidth than Raspberry Pi. So talking about the sensors, we are using a 2D LiDAR. 2D LiDAR scans one line at a time, and it rotates using a servo motor. So basically it scans one rectangle below the drone in one scan. And it takes very less time, and it is also very efficient. Our drone is actually very cost effective, as we are not using any ready-made sensors like depth camera or stereo camera. We are using self-made algorithms and basic sensors like camera and the LiDAR. So the LiDAR will help the drone to scan the arena. It will create data points of XYZ, and it will create a map. Using computer vision algorithms, the map is converted into a depth map, and using algorithms we are detecting the safe spots of given area. Actually we want to give you a better explanation about the coding part. So may I please ask my coding lead to join me. Rushikesh.
Automatically you are doing? You are doing automatic?
Yeah. Hello sir, my name is Rushikesh. I am the coding lead for our team, and I would like to tell you about our novel scanning method. So instead of using the usual depth cameras, which we can get pre-made everywhere, we are using a 2D LiDAR sensor. It captures one slice of our 3D space. So if the way we are orienting it, it is currently vertical. So it will capture a slice in this plane. To get our 2.5D map, we are rotating the LiDAR about an axis along its plane. So it will rotate like this. As it sweeps over the surface, it will get 3D data points, and we will construct these into
the scanning is by what? That scanning will be by?
The scanning will be by a servo.
Yes. And you don't have a problem in east, I think it will be facing their periphery also will identify, isn't it?
Yes, it has a range of about 7 by 8 meters centered on the spot of the drone. We have 3 strategies to cover the arena. Our first one will be to start from the starting spot and go to a predefined corner. So we have defined a direction which is at 45 degrees to the drone. It will keep moving in that direction until it hits a boundary. Then it will keep moving along the boundary until it hits a corner. So that will be its reference point. And from there, it will go 3.5 meters towards the center, like away from the corner. And then it will start scan.
Autonomously, you will be able to do,
yes.
isn't it? After you give a start, it should
yes.
suppose. Okay, good. Very
No, that movement is only for getting a reference of the arena. The scanning will be, like as it gets new spots, it will land on them and then continue scanning.
So the moment you find, how do you identify a safe landing place?
Okay, so once we get the 3D map, we get these data points in 3D space. We convert them into an image for which each pixel corresponds to the height of that point. Then we apply an OpenCV algorithm called variance, by which for each pixel. Okay.
Proceed.
Thank you.
So shall we just continue the explanation?
Okay,
sure.
Thank you, sir.
Thank you, sir.
Okay, sir.
And Nimish, the data you are going to show, what you are going to show here, the video or base station you can show? Okay. That can be shown? Okay, they are arranging.
Check.
Go ahead with that.
So
Orientation check. Rishikesh? Orientation check.
There would be 2 base stations for our case because we have to start the command on terminal on one base station. And all
RC is
the
on.
telemetry and all the maps would be displayed on.
Aryan,
main base
RC is on.
So it would
Ankit?
Thank you.
Okay. He's just
Nimish, you can announce also some. Take a mic and you can just announce the activities. Yeah.
Okay, yes. Okay. Making run. Started.
We're increasing the height to 3.5 on the base station.
Now the drone has taken off to 3.5 meters of height. Now it is finding the first corner so that it can have a reference of the arena.
Edge detected. Second edge detected.
All the edges detected.
Okay, kill.
Anti-clockwise check progress. Anti-clock.
Nimish, double side में
Not yet. Scanning is not started.
We will get another push one. fine, no? Everything is working. No. Nothing is hanging, for sure. LiDAR फक्त थोडं हलवून बघ. Okay, LiDAR बघ. Good, like that. LiDAR बघ.
meter.
Disturbed in between it seems. So suddenly it added some error. हाँ ठीक है पर मैं बोल दूंगा ओरिएंटेशन चेक
Drone bridge.
Raspa is not visible. Drone bridge. ESP is not connected. Orientation check. Battery connected. Nothing is hanging. Okay. Connecting. Ready with RC? Still not coming.
Mic le mic.
कुछ बताना है? Excuse me, sir. Actually, one of the connection has broken, so we have to resolder it. So maybe take 10 minutes for that task.
Yeah. If you can complete in 10 minutes, you can go. Otherwise, you can.
Yeah, sure. Thank you.
Come back.
डबल सोल्डरिंग गन ला रहा है
कार्ड जितना आणि मग सोल्डर कर ESP जितना कार्ड आणि मग सोल्डर कर अभी क्राउड मत करो उसको थोड़ा दूर रखो तब तक ये बैटरी चार्जिंग में इधर है तिकडे आहे पोर्ट कौन सा पेन ड्राइव चाहिए और किस लिए चाहिए
area is covered. Nothing is skipped. Yeah, it will start scanning at this point. Then this first scan will
You don't know that this is the safe landing. See, at least from here when it is scanning, does it follow some sequence?
yeah, that is the sequence. Actually,
What is the sequence?
If there was no safe spot here, still it would have taken a step. The scanning points are coded such that all of the arena is covered.
What is the pattern we are following to scan? That is the question. Pattern. Like what is the logic you are following to scan?
That's kind of a
So we figured out the cause of the error here. It was due to the localization. It stopped for a few seconds when the drone was here. So it was unable to tell that it had actually moved. So it just kept going in that direction. Yes. Yes. So it was unable to tell its own position. So even if we had put a limit, then so it is continuously moving here, but suddenly you will see it skips ahead. No. See, sir, it skipped. Here we were recording the video, so we think it was because the video was too large and it was spending time writing the video. So we have disabled that now and we are trying. Okay, sir.
Vishesh, one more doubt there.
What you want to do? Say suppose you identify this corner.
Yes.
What you are supposed to do?
Then we move away from the corner, so that would be 45 degrees like this. We've set it on a distance of 3 meters. So it will move to roughly some central part of the arena, and then it will start scanning.
From here it goes to the center part of the arena. Then it starts scanning.
Yes.
It is from here it can scan the whole.
So it cannot scan the whole thing, so we don't move it to the exact center. We move it a little short, so one scan can take, let's say, a quarter.
So you move to some point.
Yes,
it
sir.
will scan.
Yes. If it finds a point, it will land there.
And
yes, sir. Yes. Yes. If there are any safe spaces in this area which it has scanned, then it will find them. Not specifically that point, in the region around.
And also between all the scans there would be overlap.
you have some options to manually abort something, manually stop, and if it goes to unsafe, you just take care. If you have manually, if you can do something, you do it. Don't worry about the full autonomous. Huh? Yeah. And any safety manually you want to do, take care. Okay.
So because of this we are making certain changes right now. We are reducing the height of the drone from 3.5 to certain lesser range. And instead of starting it this side, we are aligning the drone in the same position, but we are instead starting in the top left right. Actually height is not the issue, but because of the height it is hard for us to take manual control. And it is hard for us to take manual control and safely land it before it crashes. Yeah. So at a safer side we are taking a this one. Yeah, it doesn't happen. At least till 5 meters it doesn't happen.
You are using depth camera or you are using stereo vision camera for the depth?
No, neither. We are using a normal wide angle Raspberry Pi camera module 3. So it covers all of the things including the localization. The stereo camera and the depth camera are used for scanning. So we are not using camera at all for scanning, we are using a LiDAR.
And then optical flow sensor also you are not using here? you are deriving from that, you said you are derived the algorithm from using the Raspberry Pi. Okay, thank you.
Yes, sir. Yes. Any more doubts? Thank you. This time the drone will not start at this side. It will take the shorter edge. Thank you. Yeah, thank you. हा कोणाचा? कोणी दिला? ओके, ठीक आहे. So this mic of one of okay. I thought it is from one of the judges.
Orientation check. RC is on. Unkilled. Setting height to 2.5 meters.
Also do the level calibration as well.
Okay. Calibrator level. Rebooted.
Okay, ready.
Ready.
Mode change.
So telemetry data is visible here. Okay. Let's start.
Three, start. The drone is arming.
The drone has taken off. So it detected the yellow corner and now it is going to the first scanning spot. Now it has increased its height so that a larger area can be scanned.
Detected. Correct.
So it is heading towards the first landing spot.
Precise scan.
Now it has reached there and it is taking a precision scan so that it does not land outside the safe spot.
All spots detected, okay?
So there seems to be some technical glitch. It should have landed on that spot, but it seems to be going to the other spots.
So it has also detected the inclined spot, so it is taking a precision scan over that one. It detected the third spot as well, so it is heading there and it is taking a precision scan there. Unfortunately, it is not landing on any of the spots, but it has detected them. We can try to correct it if we want.
If you want to manually control further, you can do it. Okay.
No, not manually.
Or you have to feed semi-autonomous. Okay.
Manually landed, Rushikesh?
No, semi-autonomous you can feed.
Let it land. Let me see. Landed.
You can explain what was the...
Detected all the spots, but for some reason, unfortunately, the code.
Okay.
Just 1 minute.
Can you tell what was your role in this?
To make sure that.
Sir, we'll show you the image. We'll get the coordinates here.
Sure that it doesn't crash. In case it loses control, I'll just take manual control. Like right now, it refused to land, so I manually landed. Yeah, I did it because it was supposed to land, but for some reason it didn't. So we'll check the code once. You can explain the image.
Yes,
I detected all the. Yeah.
We'll check what was the error and we'll try again, get it to land. In the final explanation, we'll give all these images that we've captured and explain. Yes. So wherever we see green spots in this image,
semi-autonomous mode, you can feed the...
And this is the drone position. Okay, sir. Okay, sir.
Semi-autonomous mode, you can feed the coordinates and land also. No, no, manually it did after going there.
This landing was manual. The landing was initiated, but after that it was not controlled. Actually, the drone should have landed on all of the 3 spots after detecting them, but actually probably the landing function was not called or something like that. So we had to land it manually. So we are correcting that issue right now. Yes. Yes, we'll show the maps in 1 second. So this is the first scan which was taken at a higher height, and this scan contains the whole arena. The purple dot here denotes the position of the drone, and these 3 green dots denote the safe detected landing spots. And all those red spots are detected, but they do not match the area constraint of the safe spot or the aspect ratio of the safe spot. So they are denied, and only the green ones are the ones which are safe to land. So these were detected. Next scan. Yes, sir. Actually, our algorithm cannot tell the exact angle of the slope. So after a certain incline, it doesn't accept it, but at some angle, it accepts it.
So
but
it is go, no go kind of.
yeah, it is not a perfect thing.
So you cannot tell what was the slope.
Yeah.
You can tell it is more than 15 or less than 15.
No, we cannot tell in degrees what was the slope of that. Yes, this specific spot was sufficient, safe.
It's a grid resolution. That grid resolution, how much is there here? Six
640 by 480.
That,
Yeah.
640 means that 12. This one that
Yeah,
30
the
meters. That way it is.
Yes.
30 feet.
Nimish?
Yes, sir.
Which are the sensors which are used in order to generate this map?
To generate this map, only one sensor was used, which was the 2D LiDAR.
2D LiDAR?
Yes. And it scans, it uses a servo to sweep an angle so that it scans a wider range. And using the drone's localization, we know the exact location of the drone with respect to the map.
Show the previous image?
Zoshi, Atharva, previous image, the map. Actually, he is working on that on another PC. So,
Okay, you can explain that. You can explain how you.
Yes, sir. So actually, the main error what happened here was that the precision scans did not detect the safe spots. That's why they didn't land there. So during the precision scans, it got denied. In the main scan, it got accepted.
There are so many polygons there, no?
Yes.
To make out, which is the safe thing? How you have identified the safe one?
Actually, on the depth map, it adds some filters like blur and variance, and it creates this certain map.
Okay, now this, how you are able to identify the safe landing area?
There are a few aspects. The first one is the area. So we have, for every height, there is a certain area range which is acceptable for the drone to land. Another variable is the aspect ratio, that the area must not be very long. And one more thing.
And one more thing is the variance. So we scan the pixels. If the pixels variance is more, like we'll get the pixels height also in camera, right? So if the spot is flat and the other point means अगर ये flat spot है और ये कुछ नहीं है तो इधर के pixels match नहीं होंगे और उसमें variance होगा तो इसकी वजह से वो flat spot detect होगा.
Sir, so previously we were using the Laplacian operator for the flatness detection, so it was calculating the double derivative of x and y and then giving us the radius of curvature. But then now we have switched to this variance method where if we have similar points, they'll have a low variance, and if there is a outlier or something like that, so it's going to be a high variance and that won't be detected as a flat spot. So that's the reason. And green spots would basically mean the safe ones, and the red ones are the ones because of the area constraint and the aspect ratio, we have ignored them. And the purple dot is basically the drone position.
Okay, just one question here. This yellow boundary you are detecting by a different sensor? Like a different
No,
camera?
actually, there were two methods for the boundary detection that we were doing. First, we filter out the HSV range, so we get the yellow color out of it. And what we do is for every yellow pixel, we create a vector that is opposite to it. So it creates a force for the drone to go in the opposite direction. And that way, whatever yellow pixels are there, it will always create just like the electromagnetic distance kind of logic that is there. So for each distance, there's a corresponding vector that comes in the opposite direction. So it'll move the drone in that direction. This was one method, and the other method that we thought was of using the convex hull method from OpenCV. So this is going to again take the HSV range only, and then there's this inbuilt library of the OpenCV where we use this convex hulls and then convexity defects. So from the yellow pixel, it'll take the deepest point where it finds a concave edge. So that's for the corner part.
So you are not using camera data for detecting?
Yeah, we take the camera feed, and from that only we take the HSV range.
Your LiDAR is scanning. So how good is
LiDAR
the
is-
match between camera coordinate and the laser coordinate?
Yeah, so the LiDAR is for the safe spots only, and the yellow color only for the boundary detection, we are using the camera. Yeah, so that's it.
Fine.
Excuse me? How are you identifying the boundaries here? So in that image, no, how are you identifying the boundary?
The yellow boundary or the safe spot
Yeah,
boundary?
yellow one.
Yellow boundary, we are using two methods. One as a fallback one. The first one is to basically take the HSV range for the yellow color, and after we detect the yellow color, for every yellow pixel, there is a vector that is created in the opposite direction. So that way it will take the drone in the opposite direction. So it's like an invisible wall.
But is it representing there in the image?
Not in the image,
Not
only
in the
for the
image. It
camera
is algorithm only.
yeah, only by the camera we tell that a corner was detected, and so the drone knows that it has to move away from it. The other fallback mechanism that we had was using OpenCV, where we use this convex hull and convexity defects functions. So it takes the deepest point for the corner, and then over there it sees that there is a concave kind of a shape detected, so that means it's a corner.
Which one it has used here?
Currently
one,
we are
first.
using the vector one. Yeah.
So in vector, if the drone is away from the yellow boundary, so the vector would be small. But if the drone is near to the boundary, then the vector would be large. That is, it is in the inverse proportion of its length. Matlab, we would know that drone is far or near to the boundary.
But whether you will get any singularities, suppose if it is just on the boundary, the length will be almost it is 1/0, no?
So for it, matlab, if it is near the boundary, na, so vector would be more, indicating that the drone is near to boundary. Like you have to move up.
So you were telling about that precision scan thing did not work. So what is the criteria? Like earlier you were able to find the spot, but finally you were not able to land. So what is that like? What is the other criteria for landing? Like what?
Precision scan is basically the second verification criteria that we use.
Yeah.
So the first scan, it did detect it as a
Yes, sir, we are ready.
precision landing. That time it did not detect it as a safe spot.
No, why means precision landing? What are you checking?
So sir, in the precision landing, we are making sure that there is no shadow artifacts.
Okay.
So if it's been taken from a central position,
Yeah.
a rock may cast a shadow like of the LiDAR
Okay.
onto this spot, and the center may not be perfect.
Okay.
So we
So,
go
so
to
this texture is okay for you? Whatever the textured thing is?
Yeah, it's fine. But if there were some bigger obstacles, then it would be a problem. So we are taking the precision scans.
Okay.
Right now, the precision scans failed because we considered the maximum height of an obstacle to be 1 meter. So it was detecting this wall
Okay.
and considering this to be an obstacle. So
Okay.
the rest were scaled down to match it. So the data is normalized in many steps.
Okay.
So compared to this, all of the other rocks were not very large. So they weren't detected as big obstacles.
Thank you.
So in the central one, we didn't detect this edge because it was far away. So the scan succeeded.
Okay. Okay. Thank you.
Thank you.
Rushikesh, we can continue the run.
Okay. Ready?
Orientation check. Calibrating level. Okay, calibrating level. Rebooting compass. Okay. Mode. Mode stabilize. Stabilize, yes. Okay, that's all. Connected.
Setting the height at 2.5. 1, 2, 3.
The drone has taken off, going to the first corner, detected, reached the first point for scanning. Toshit, are the coordinates visible?
No, actually.
Okay, okay. The spot is detected, it is landing autonomously.
Okay.
And there was no manual intervention at all.
Will arm again. Arming.
It is taking a precision scan at the third spot
Detected and correct. Landing. Till arm again.
Now it is returning back to home.
Okay.
Actually, the home spot was approximately detected. That's why Aryan had to take a little bit control while landing on the home spot at the end.
Very good, excellent. And after stopping at that point, it was automatically trying to take off after the first part. Arming, you were telling arming, it's autonomous.
Yes.
Okay, no, just for as per plan, it was autonomously taking off. Very good,
Yes, sir.
excellent.
Everything
excellent.
was autonomous.
Oh, very good, nice. Only.
So.
Very good. They say third spot it could not identify the slant one, or what was the reason?
Sir, we'll check the logs. Are we allowed to restart? Just one more run?
Just one more run to verify.
One last one.
Okay, go.
Thank you so much.
I just took the controls while it was landing because it wasn't able to detect the landing spot, the home spot correctly. Otherwise, everything was autonomous. I was just here to take landing, at the time of landing, just at the home spot, not at the any other spots.
So.
Everything was autonomous.
Landing is not manual, autonomous. Right from everywhere it's autonomous.
Only for the home spot, it was manual.
Oh, last home position was manual.
Yeah, the last one.
Okay.
Other than that, the safe spots, it was automatic.
Okay, fine, fine.
I mean, I can do anything with it manually, but like that is only for safety. Like if it loses control, then I have to take control of it, which it didn't. Oh, okay. If you want, I can like hold the.
No, there is no gyroscope sensor in the remote.
I'm not using it. If you want, I can hold
Just trying to show you that is not controlling. Yeah, only one part was manual. Actually, the last home spot coordinate was not exact. That's why he took it manual. Otherwise, all the landing and all the takeoffs were autonomous.
It has gone to the home spot, but on the landing time you have intervened. Return to home spot was correct.
Yes, it was correct.
How much time will you take to do it again? You were telling, no, you want 5 minutes.
We have an extra.
We all are.
There are scans. There are scans. If you want. Scans.
You have to change the battery, is it?
So this is the main scan. Once again, it detected all the 3 safe spots in the first scan. And this is the purple dot which denotes the position of the drone while scanning.
With the battery, we are doing a return to home as we did right now, but it is not very precise. Again, we can demonstrate it. We can show it now.
We can show it to you. There is no dead battery.
नहीं नहीं है ना अभी की depleted
We have a depleted battery, so
we can increase the threshold voltage to show the failsafe.
battery failsafe दिखा सकते हैं.
Yes, sir.
Link failure.
It will go to 0 0 and land as it did for both battery and.
If you can demonstrate that also is fine.
Yes, sir. We'll do.
The link failure you will demonstrate or battery failure, one of them will demonstrate.
Both of one of them.
That's okay.
So this one was detected.
If you have to do, it may take some time, no?
The same run we have to repeat.
Yeah, because. Okay, for doing that repeat, how much time it will take for you? 5 to 10 minutes.
Just right now, it's ready right now. We can
battery.
We can swap it out right now. Yes, sir.
Okay, sir. Should we give
the
them a
problem
chance?
with this spot was it was detected to be outside of the arena.
Okay. Oh, okay, quickly.
It has detected,
Quickly
but it is said it is outside the arena.
Next attempt, you go for the one more attempt now.
Yes.
The last attempt.
Okay.
Yeah.
We will
go
set
ahead.
the threshold to be closer to the arena. Yes, sir. Yes, sir.
Good. Sir, it's not bad.
Okay. Actually, just 2 minutes. He's changing the code a little bit. Meanwhile, I will tell a few points more. Actually, during the last round, the scientists visit, they suggested us some improvements, like there is not a perfect magnetic field on Mars like on Earth. So we were initially using a magnetometer. So they suggested not to use it. So I have disabled the magnetometer, internal and external as well. We are only using the internal IMU combined with the camera feed which tells the yaw of the drone. So that is one point. Another point is that initially we did not consider that the home's safe spots can be elevated. So we have imbibed that as well. And yes. Yes. Actually, we are not fixing the initial yaw because, yeah. Actually, we are not able to control the yaw perfectly. We have tested it, but the drone. Yes, so we have not allowed it to. Yeah, we are not doing that. Yes, sir. Yes. Outside, yeah. Yeah. Yes.
Lunch has arrived. Anyone wish to, other than our expert panel, anyone wish to take, they can continue. They can go ahead. With lunch has arrived, sir. Arrived.
Next teams can go for lunch and be ready.
We have informed them. Yes, sir.
Good. That's
The incline one. Actually, it was on the edge. It was on the edge of the arena, so it considered it as like outer part. Yeah. The home position. Actually, because the area of the home position is comparatively smaller than the other spots. So when the scan is done, it is at the center, and that position is like the farthest one. So it also reduces the size a little. Yes, actually. Yes, for that reason we are doing the precision scan. We have made a little bit wider range of areas for detecting it as a safe spot. So it was detected, and after going there, it also takes a precision scan. So it considers it as safe. Yes. Actually, we did not take precision scan after return to home. That's why it was not precise. So as you can see, this is the web interface that we have created. So it shows all the telemetry X, Y, Z, your battery status, power delivery of in ampere and wattage and everything. And also the maps which are detected are displayed on this web interface.
तिकडेच थांब म्हणजे बोलता येईल मला.
Okay.
Okay, let's start. Modes change, RC. Can you change the modes, Aryan? Stabilize.
I just wanted to show us, show you guys that.
Okay. Level has been calibrated, rebooted.
You can also announce what you are going to demonstrate, because you are told only you are planning the inclined drop.
So now we are going to have it go to the inclined spot first by moving it closer to that spot. So after it detects the corner, we'll move it in this direction more. So it will first go to the inclined spot.
So how did you feed that input? Go only to that like that? No. How did you select
So
it?
we changed the code right now to make it go more towards this side.
Oh.
So whenever it sees some spots, it goes to the nearest one.
Okay.
So it will hopefully go to the
Okay,
slanted.
starting scan, favor to that part.
No, heading is the same. The displacement from the corner is different.
Okay, let's start.
Two 2.5. 1, 2, 3, start. The drone is armed.
As you can see, the live telemetry data is being displayed on the screen as well.
So here we have kept it more biased towards the slanted spot. So it should detect it first. Telemetry lost हो गया. There is a telemetry loss signal here.
Okay.
So this was the telemetry test.
Okay. Oh, that was planned for a telemetry loss test?
Yes.
No, it was not planned,
Okay,
but I
okay.
can show you the messages here.
Okay, go ahead. Thanks. Okay, fine.
Okay, sir.
This time also I took a little bit of the control just to make sure that it doesn't fall off.
You can see the messages. Should I put it in front of the camera? Here you can see there are the telemetry lost messages. So it was disconnected from the ground station which we were viewing here before.
It is visible.
Okay. Let's restart.
Actually, the battery voltage right now is 11.57 and the threshold we have set it to is 11.5. So in like under a minute, it would attempt a battery failsafe right now. Yes. Yes, battery failsafe.
Okay. Do you set the position? Orientation check. Okay? Okay.
So the battery failsafe threshold is set to 11.3 volts.
Okay.
Starting in 3, 2, 1, start. So almost immediately you can see here the battery dropped to 11.19 and it has
Actually, as soon as it took off, the battery failsafe got activated. So it did not get any time.
So in the battery failsafe, we do not do a precision scan because there is not enough time. So it was not very precise.
By the way, the home spot is 1.2 by 1.2, right? That is the only reason I always have to take controls there, because we have programmed it to only detect areas of 1.5 by 1.5. So in these one I don't take control. Like if that was 1.5 by 1.5, it would happen.
Sir, we are really sorry, but just because of the
Kaushal?
telemetry failsafe, we could not demonstrate the inclined flat spot detection. Just 2 minutes. Everything is charged and ready. Really sorry for the inconvenience, sir.
Kaushal, we'll change the battery, okay? Dhaval is bringing.
Just connect the battery first before securing it. Connect it first.
Is battery connected?
Yes.
Okay. Mission plan mission plan level calibrate कर. थांब. Orientation check.
5 minutes.
Battery is connected.
Okay. Orientation check.
Check.
Calibrating level. Rebooting compass. Showing telemetry. Okay, loiter. Three, two, one, start.
Line detected. Now going to a position which is slightly near the inclined spot.
Detected incline.
Taking a precision scan. Coordinate detected.
Detected.
Landing on the incline spot.
Yes, it will reach.
Perfect position.
Reach. Landed.
Landed perfectly.
Let's go. It will take off again. It will take off again. Okay. Arming. Fine. Okay, so I think it is finding the next corner.
It has detected the corner.
Detected another spot.
As we can see, the new scan is detected.
Okay. Landing. Okay. Kill it.
Aryan, you can kill it now. We have demonstrated what we had to. Sir, shall we continue? To the last spot?
It can scan last spot also.
Is it programmed now? Is it going?
It will continue
Yeah,
as it
good,
is.
good.
It will continue.
Yeah,
Taking off, arming.
Now it is taking a precision scan over the third safe spot, which is the last one.
New scan detected. Landing. Landed.
Are you continuing again?
You can kill it, Aryan.
You can
now.
kill it now.
All the spots are covered.
Yes, all spots are covered.
Okay, that's it. Okay, excellent. Very good.
Also about the incline spot, the drone might topple sometimes while landing on the incline spot. So we have added rubber pads under the feet of the drone so that it has maximum grip and it does not slip down.
Okay, okay.
You can take a closer look at the drone. We have brought it here.
Over here we've used an S500 frame which is 500 millimeters in diameter. We've used the Raspberry Pi 5 as our processor and Pixox 6X Mini as the primary flight controller, an ESP32 for telemetry, a separate buck and as a power module for powering the Pixox, and the buck powers the Raspberry Pi as well as the micro servo which basically turns the LiDAR from minus X degrees to X degrees, which facilitates in the map generation and scanning.
Kaushal, also mention about the self-made damper we have used.
Yes, so we found out that the below is the damper which has the Raspberry Pi camera, the wide angle camera module 3, which is completely isolated from the upper section. So this damper, we found out about it because stainless steel threaded wires have maximum friction absorbing capacity so that they absorb the vibrations from the damper, hence we get a clear field view of the ground. Yes.
It isolates the camera from the drone and reduces the vibrations significantly.
Damper as well as absorber, which is right. Then what is the frequency beyond which it will damp?
Actually, we have not measured the frequency. We have taken multiple trials yes.
Yeah. Experimentally viewed each footage starting from
So its camera stability is very good because of this.
No, that see this innovation in scanning. What is that innovation in the scanning? That what is the algorithm here? Innovation.
So we try to minimize the cost of our system, which only uses a low cost, which is 6,000 rupee 2D LiDAR and a cheap servo. And it still yields us a 2.5D map. Which
How are you calling it a 2.5 map?
So, as I said, the servo scans a slice of a 3D space because it has a rotating servo mount inside. So it captures points in a plane. So we take the LiDAR and we rotate it along an axis so that the plane sweeps across the surface.
Okay, what is the angle? It is sweeping angle that.
So right now we've set it 120 degrees. So
120 degrees.
Plus 60 to minus 60 degrees.
Okay, any that outliers? How you removed that LiDAR outliers? No,
yes, sir.
How
So
did you do that?
To
Building?
remove that, yes. So in our specification of the arena, it was given the size of the obstacles would be less than 2.5 feet.
Okay.
So we cut off any points above
Threshold
that.
cutoff. That threshold cutoff. Threshold cutoff only you have done
yes.
that. You
We
have not
cut off
used
the
any
points.
filters.
No. After that, we are using filters.
What is that filter?
We use a filter. I don't think it has a name. I call it variance. Basically, for each pixel, it takes a square around the pixel and computes the maximum and a minimum value and takes their subtraction. So it gives a measure of how fast the surface is changing.
Can you tell that what is the critical part in the entire thing? What is the critical part?
The critical part is localization, sir.
Localization.
If it does not work, even the scans will not work.
Okay, but that this border detection is done by the camera.
Yes.
How you merged that LiDAR data with this data? That our DEM data with this how that coordinate fixing and then that mapping, how totally, how you merge the map?
So we don't merge the map. We simply use the camera to detect a corner of the arena and set that as our origin.
Okay.
So once we have the origin, the localization keeps giving an X and Y.
Very good work. Excellent,
Thank you,
actually. Excellent.
Yes, so here we have a video of the localization and yellow detection.
You are using any that AI algorithms? No AI algorithm?
AI algorithm.
No AI.
Yes.
Fusion, correct. Okay, you have to explain actually that dots, all those things you have to explain your localization. Oh, correct.
Yes. So this was of the first run, which failed sadly. But so here you can see the green points are being tracked across the surface.
Optical flow.
Optical flow, yes. And you see the magnitude vector points opposite to any yellow pixels.
Okay.
So it allows us to go away from the border.
But what is the maximum speed it will go such that your optical flow is perfect? Anything limitation is there?
So we have set a limit of 30 centimeter per second. So in this whole run, it was.
Okay, but you can test with the higher speeds also.
We have tested with 50, but it crashed.
Okay. What is your that data rate? Here, this optical data rate.
The data rate of the camera is 120 FPS, but the Raspberry Pi is not able to process at that speed.
Correct. That's why I'm asking that question. What you are sampling that?
So we are doing it as fast as the Raspberry Pi can.
Okay,
It's
right.
not set at a specific rate.
Okay, yeah, all data you are storing in that memory. How you are managing the storage is this one?
So this video we are simply writing it to a file.
Okay.
But we were unable to manage it because that's why it crashed here.
But you are having the NVIDIA here, right?
No,
Processor.
sir.
What is it?
Raspberry Pi.
Raspberry Pi.
Pure Raspberry Pi.
Okay, but computational will be expensive, you know that.
Yes, sir. We thought of using an AI module, but it didn't work out.
Okay,
We were
good,
unable.
very good. Yeah.
Thank you, sir.
Fully autonomous. Fully autonomous.
With the Raspberry Pi, sir. Yes, sir. It consumes about 4 amperes. Yes, sir. So we have 3 batteries, sir. So we kept charging them, yes. Yes, we are changing and charging them.
We have seen that with one battery we can have a lifetime of around 7 to 8 minutes.
We have actually made all the mounts using 3D printed PLA material. That is why it is very lightweight. And the frame also has carbon fiber forged rods.
So the LiDAR is rated for 12 meters, but that is electric power. I'm not sure, sir. I'll have to check. But by far the Raspberry Pi is the most power hungry element of it.
One question you can just just
All these things have been.
No, sir, we haven't done. We have cut down on weight.
All the 3D printed.
The battery tries to go to home, but it is usually incorrect, so it lands there without taking.
Stuff is what you have taken. What are the other things that you have built over there?
Yes, other things are the 3D prints we have built over that. This is the PIXOC casing which protected it during the first fall. One broke and this is the second one casing. This is the Raspberry Pi casing. The most novelty we have is the damper which we are using, which basically isolates the Pi.
Our college doesn't have any mechanical branch.
So we are only researchers.
We did some research on it
and the CAD design was done by me. And
the most unique selling point that we have is the lack of a magnetometer.
Yes.
You have done stress analysis? Actually, we tried
a stress analysis was also experimental.
So we did not do stress analysis.
50%, 70%, which are
for the 3D prints.
This particular thing acts as a action device.
When the drone flips.
Upside down. That time this
particular thing will get damaged.
Sometimes the obstacle may be like this shape and it might
So it is only, it depends on the shape of the obstacle.
Yeah. So why take a chance? Keep it safe.
Throughout the multiple months that we have tested it, this generally doesn't break, but the PICSOC is very important, so that way it needs some implementation.
Can you just identify the different sensors? This is one thing which is clear. It's a camera, which is your depth camera.
We are not using
We are not using a depth camera.
And this is your optical flow sensor.
This is a simple camera, Raspberry Pi camera.
And the optical flow algorithm is custom.
Using as the primary rangefinder for the
This is the 1D LiDAR and this is the
2D.
Yes, sir.
1D ladder only gives the height, and this is for math.
Since this doesn't always point down, it is unable to always provide a height. Yes, sir.
How do you mean by precision scanning?
So the localization is not always correct. No, no, sir. It is simply another. It is exactly the same as the normal scan.
But close to the
Because it is done right above a safe spot. Like we know we are. To make sure that we are at the center.
To make sure that we are standing on a safe. For the remote control, this is the receiver. And for the base station, this is the receiver. Yes.
So it can run without this one even, but this is for safety reason we have kept it.
Yes.
Yes.
Yes, we have to keep changing it because
Yes. Yeah. Sir, the
So it needs to have reduced vibrations and
Excellent performance.
Thank you, sir. Thank you so much.
Thank you very much.
You can come for one photo.
We'll go for lunch.
Please go ahead for the lunch, sir. So sheets shall we collect after some time, sir? Request all evaluators to submit the sheets to the chairperson with signature.